Okay, so we're in chapter 2, and like we just said in the last lecture, we're doing the equations of motion with constant acceleration, and they are right here, and they're in your notes, and we're going to move on, and we're going to do at least one example problem in this video. Okay, so what we're going to do is, I just got back. I just went out and drove my car around a little bit on dirt road next to the school, and what I found is, okay, we're going to start off with this chart. We really want to start off with this chart. You want to start off putting this chart in place. Okay, so I'm going to start off with this chart. X, T, VI, VF, A. Now, what I did is I went from an initial speed of 20 miles per hour to a final speed of 40 miles per hour in 1/10 of a mile. And I want to know what time did it take and what was the acceleration. Well, first off, for some reason, I am quoting you this in English units, and we don't want English units. So all of these must be replaced. So you'll remember that 1 mile equals 1,609 meters. So I'm going to say, well, I'm going to cut out this part. I'm going to say that 1/10 of a mile is 160 meters. So I went 160 meters. That's the important number. I don't care how many miles I went. Now, you'll also remember that 1 meter per second is 2.24 miles per hour. So that means that I have to take 20 miles per hour over 1 times 1 meter per second divided by 2.24 miles per hour. And so I'm going to get my initial speed is going to be 20 divided by 2.24. So my initial speed, I'm going to call it 8.9 miles per hour. I'm sorry, 8.9 meters per second. 8.9 meters per second. And then you can hit pause and do the exact same thing with 40 miles per hour. 40 divided by 2.24 is going to be double 8.9, so it's going to be 17 point, we'll just call it 17.8. We're not being super precise here. We're actually already being more precise than we really should be. Alright, so now I have initial speed, final speed, and distance. Now, what do I want to find first? Well, let's find time first. Well, if we're going to find time first, that means that we don't care about acceleration. Well, so which one of these equations doesn't have acceleration? This one doesn't have acceleration. So I'm going to copy it down right here, and I'm going to say x equals VF plus VI over 2 times t. Now, the way that I want you to solve problems is I always want you to write out the equation before you plug in the numbers. Always write out the equation in symbols before you plug in the numbers. Now, let's put my numbers in. I have 160 meters equals VF is 17.8 meters per second plus VI, which is 8.9 meters per second, divided by 2, that whole thing divided by 2, and then we don't know T. So T stays as T. Okay. Now I'm going to rearrange this. I'm a big fan of just doing everything out on your calculator in one step and not doing multiple steps. So I'm going to rearrange this. I actually should have probably rearranged it with the symbols up here. But I'm going to say T is equal to 160 times 2 divided by that. So I'm going to divide this by this, which is the same as taking this times the reciprocal of that. So I'm going to say 160 meters times 2 divided by 17.8 meters per second plus 8.9 meters per second. And let's plug that into our calculator. 160 times 2 divided by, here's where we need parentheses, 17.8 plus 8.9, hit it, and I get 11.985, and I'm going to say that is going to be 12 seconds. Okay, so what I'm saying is that it took me 12 seconds to go from 20 miles per hour to 40 miles per hour over 1/10 of a mile. Now, what's really funny is I had my stopwatch with me and I cleared that out. I don't think it's probably in there. I cleared it out. But what do you think that I read on the stopwatch? Well, it wasn't 11.98. It was probably more like 12.13 or something like that. But it was close to 12. So I actually did measure the time that it took, and it was close to 12. Now, the last thing that I want to do is I want to figure out the acceleration. I'm going to copy that time up there, 12 seconds. I want to calculate the acceleration. So I already know time, but suppose that I made a mistake with the time. Suppose I did this calculation wrong, or suppose you did the calculation wrong. Well, let's not even use that 12 seconds in our new calculation. So let's find the equation that does not contain time. Well, the equation that does not contain time is this one right here. Does not contain time. So we've got VF squared equals VI squared plus 2AX. Now I want to arrange that for A, so think about, hit pause, think about how to arrange that for A. Alright, if you do it out, it's going to be VF squared minus VI squared divided by 2X equals A. So, I'm going to go 17.8 meters per second squared minus 8.9 meters per second squared divided by 2 divided by 160 meters. That's going to be A. Alright, running out of time, so we're going to do this a little bit quick. Pay attention to how I plug this into the calculator, because this is going to go by a little bit fast. I am going to go 17.8 second, well, don't need that, squared. Well, sorry, gotta go back. I'm going to need parentheses for the numerator. 17.8 squared minus 8.9 squared. That takes care of my numerator. Divided by, now I'm going to use parentheses for the denominator, 2 times 160. I need those sets of parentheses. 2 times 160 is the denominator. Hit it, and I get 0.74. What are the units on that? A is 0.74 watts. It's going to be meters per second squared. Okay, that's it for that example.